Hello everyone, myself Mr. Kiran S. Chinswalkar, lecturer in Mechanical Engineering Department from Praveen Patil College of Diploma Engineering and Technology. We study chapter number 1, Fundamental of Machining and Machining Operation, part 4. Learning Outcome. After watching this video, you should able to classification of drilling machine. Second, specification of drilling machine. Third, drilling machine operation. And fourth, cutting parameters for drilling. Now we study what is drilling. First point, drilling is the operation of producing cylindrical hole by removing metal by the rotating edges of cutting tool called the drill. Second point, the drilling is one of the simplest methods of producing a hole. Third, before drilling, the center of hole is located on the workpiece. Then center punch is used to produce an indentation at the center. Fourth point, the drill point is pressed at the center point to produce required hole. Now we study classification of drilling machine. Drilling machines are manufactured in various types and sizes to handle various jobs in a machine and assembly shop, maintenance and repair shop, in the tool rooms of manufacturing unit and many more places. Different types of drilling machines. The drilling machine classified as follows. First type is a portable drilling machine. Second is a sensitive drilling machine. Third is a column time drilling machine. Fourth is radial drilling machine. Fifth is a gang drilling machine. Sixth is a multiple spindle drilling machine. And seven is a deep hole drilling machine. These are some different types of drilling machines. Now we study each of these drilling machine in details. First is a portable drilling machine. As name, as name implies, it is a small, compact, lightweight, self-contained drilling machine, which is used to drill hole on a stationary installed components, which cannot be brought to conventional workshop. The machine spindle is rotated by self-contained electric motor. Machine is operated at higher spindle speed to generate small size hole. The advantages with a portable drilling machine is that the hole can be drilled at any inclination. We can see the portable drilling machine in this diagram. At the tip of the drill machine there is we fit the drill bit and various accessories we are uses for drilling the hole in the various applications. In this slide we study sensitive drilling machine. Sensitive drilling machine is a simplest types of drilling machine mainly used for light duty work. It consists of a base, vertical column, head supporting the motor with a driving mechanism, rotating drill spindle, and horizontal table. Base may be mounted on table or on shop floor. Rotational speed of electric motor is transferred to a drill spindle through a V-belt arrangement. To get the speed variation, step cone pulley is used. By shifting the belt on cone pulley, different drill spindle speed can be obtained to suit work condition. Drill spindle is fed purely by hand control. No power feed is available. High speed and hand feed is necessary for drilling small holes. High speed are necessary to attain required cutting speed by small diameter drill. Hand feed permits the operator to feel or sense the progress of drill into work, so that if the drill becomes worn out or jam on any account, pressure on drill is released immediately to prevent it from breaking. As the operator senses the cutting action, it is called as sensitive drilling machine. Horizontal table is clamped to vertical column. The table can be moved up and down according to size of workpiece to be mounted. Top of table is provided with T-slot to clamp the workpiece. Sensitive drilling machine is capable of drilling hole of diameter from 1.5 mm to 15.5 mm. Next drilling machine is column type drilling machine. Construction of column type drilling machine is similar to sensitive drilling machine, but column type drilling machine is heavier and larger than sensitive drilling machine. Column provided is of round or box section. Work table of machine may be moved up and down to accommodate job of different size. Work table can also be rotated 360 around the column. Column type drilling machine is provided with a power feed. Column type drilling machine is used for medium size hole. Next machine is radial drilling machine. Radial drilling machine is most modern machine used for drilling medium and heavy jobs. Drilling machine has a capacity to locate any desired hole position on heavy jobs. In case of radial drilling machine, without disturbing the setting of work, many holes at desired position may be drilled. Radial drilling machine consists of basic parts like a base, column, radial arm, and drill spindle head. Huge column of round cross section is mounted on the base. Columns support the radial arm, which can be raised or lowered with electric motor to accommodate the job of different size. Radial arm can be moved in a 360 in a horizontal plane to locate the hole on a large workpiece. Radial arm carries a drill head. Drill head can be moved in a horizontal direction on guide ways provided on radial arm. Drill head accommodates drill spindle and motor for driving drill spindle. Drill spindle can be moved up and down to adjust workpiece of different heights. Apart from above more moments, universal radial drilling has one more moment to drill the hole in an angular direction. That is, radial arm can be swiveled with some angle. Thus, universal radial drilling machine have 5 different moments. Next machine is gang drilling machine. Number of single spindle drilling machine column are placed side by side on a common base and having common work table is called as a gang drilling machine. Gang drilling machine consists of 4 to 6 separate drilling heads arranged side by side. In some machines, column of each spindle had a permanently attached to base, or in some machines column may be moved to vary the distance between the column. Speed and feed of spindle can be controlled independently. Each spindle may be set up properly with different tools for different operations. A series of operations may be performed on work by simply shifting the work from one position to other on work table. Next drilling machine is a multiple spindle drilling machine. It is a special drilling machine used to drill a number of holes simultaneously to produce identical pieces in a mass production. Machine has a several spindles driven by same motor and all spindles are fed simultaneously. Feeding motion is obtained by raising the work table. Drill jigs may be used to guide the drills in a mass production. Now we study specification of drilling machine. There are various factors to be considered while specifying the drilling machine. Drilling machine may be specified by providing following information. First is a maximum size of the drill that the machine can hold. Second, table size. Third, maximum spindle travel. Fourth, number of speed and feet of spindle available. Fifth, motor speed and power. And sixth, overall dimension of the machine and weight. Now we study drilling machine operation. Various drilling machine operations performed on a drilling machines are: first operation is a drilling, second is a reaming, third is a boring, fourth is a counter boring, fifth is a counter sinking, sixth is a spot facing, and seven is a tapping. Now you see the first operation. This is a drilling. Drilling operation is seen in this above diagram. First point, it is an operation which involves production of cylindrical shape hole by removing metal by rotating edge of cutting tools called as a drill. Second point, before drilling, the center of hole is located on a workpiece and center punch is used to produce an indentation at the center. Third, drilling does not produce an accurate hole in a workpiece. The hole generated by drill is always slightly oversized than the drill used due to vibration of spindle and drill. A 12 mm drill produces hole of 12.125 mm. Next operation is a reaming operation. Reaming is the accurate way of sizing and finishing a hole which is previously drilled. Second point, in order to finish the hole and to bring it to accurate size, the hole is drilled slightly undersized. So, reaming is not generate hole, it's only finishing hole which are previously drilled. Next operation is a boring operation. First point, boring operation can also be done on a drilling machine. Second point, boring is the operation of enlarging the existing hole. Third point, boring is done to enlarge the hole by means of adjustable cutting tool with only one cutting edge. Fourth point, this is required where suitable size drill is not available or where the diameter is so large that it cannot be drilled. Fifth point, boring is done to finish a hole accurately and bring it to required size. Next operation is counter boring operation. Counter boring. First point, it is the operation of enlarging the end of hole cylindrically. The enlarged hole forms a square shoulder with the original hole. Counter boring is necessary in some cases to accommodate the heads of bolt, studs and pins. Tool used for counter boring is called as a counter bore. Next operation is spot facing operation. Spot facing. The operation of smoothing and squaring the surface around a hole for a seat for a nut or head of the screw. A counter bore or special spot facing tool may be used for this purpose. Next operation is a tapping operation. Tapping. Tapping is a cutting of internal threads using a tool known as a tap. Second point, tab can be considered as a bolt with the accurate threads cut on it. Thread act as a cutting edges, which are hardened and ground. Third step, when tab is screwed into a hole, it removes metal and cuts internal threads, which will fit into external threads of the same size. Now we study cutting parameters for drilling. First parameter is a cutting speed. The cutting speed in a drilling operation refers to the peripheral speed of a point on the surface of the drill in contact with the work. It is usually expressed in meter per minute. The cutting speed is calculated as cutting speed is equal to pi into d into n divided by 1000, and unit is meter per minute, where small d is equal to diameter of the drill in mm and capital N is equal to RPM of a drill spindle. The cutting speed is maximum at a periphery and it is zero at the center of a drill. Now we see the cutting speed depends on the following factors. First factor is the kind of material being drilled. Softer material require higher speed and harder materials require slower speed. The second point, the cutting tool material like HSS drills can be operated at a higher speed than high carbon steel tools. Third, quality of surface finish desired. Fourth, type of cutting fluid used. Fifth, method of holding workpiece. And sixth, the size, time, type, and rigidity of drilling machine. Next parameter is a feed. Feed of a drill is the distance the drill moves into the work at each revolution of the spindle. It is expressed in a mm. It is also expressed as a feet per minute, which is defined as the actual distance moved by the drill into work per minute. Feet per minute is equal to feet in mm divided by revolution into n, where n is the RPM of a drill. The, the amount of feed depends on first is the hardness of material, second rigidity of job and a machine, third is the depth of hole, fourth is the type of finish desired, and fifth is the range of feeds available. Next parameter is the depth of cut. The depth of cut is a drilling is equal to one half of feed. Thus, depth of cut is expressed as depth of cut is equal to feet divided by 2 and unit is mm. Next parameter is a machining time. Machining time is a drilling is defined as T is equal to L divided by N into F and unit is minute, where capital T is equal to machine time in minute, capital N is equal to RPM of drill, small f is equal to feet per revolution of drill in mm, and L is equal to length of travel of a drill in mm is equal to D plus zero point 0.3 into D, where capital D is diameter of hole and small d is the depth of hole. I hope you understand this presentation. Thank you.